Hello and welcome to Frog Appendix number probably 8. We are here to address some topic regarding the VFC guns, and we will show it based on this beautiful BAM VFC, sorry, it's not a VFC, obviously, it's APFG MCX, the 13.1 carbine version. Yeah, of course, UKSF is strong with me. What this video will be about is how to make your VFC APGF MCX run well. This is a third generation gun, and the same lessons, let's say, we will take from here, they apply also to like any VFC third generation gun, okay? And this is mainly dedicated for the HPA, regardless of if you use the TheFrogEngineer conversion or any HPA tap, the method will be the same, and it will yield some good results. But for the green gas it can be counterproductive. So why? We will talk in a second. And this is all linked with the direction in which VFC is going with all their GBBRs. The same for the 7.62. So if I remove the upper receiver from this one, you can see it's already converted to HPA, but that's not the topic of this video. The topic is the third version of the GBBRs from VFC. So you see that the hammer strikes only the silver part, which is called the valve knocker, and there is no valve knocker retaining lever here. Yeah, so if I pull the trigger, it pushes in the valve knocker. If I move the hammer back, you see it comes back. Yeah, so this is the third generation, while in second generation it was a bit different, and for our HPA guys better. Why? Because here we have this latch or lever here, yeah, which works the following. If I now pull the trigger, the hammer strikes the valve knocker, but if I pull the hammer back, you see valve knocker is retained and it doesn't go to its original position until I press this lever. Yeah? So again, the shot happens, and when I press this lever it moves a bit back. Of course, this lever goes up, it is interfaced with the bolt carrier, so the bolt carrier rides on top of it, it pushes this lever and makes that part go back. Okay, so this is the difference between the V2 and V3 VFC gun. So first question, why VFC is removing this, not just from the 5.56 guns but also for the 7.62 guns? Yeah, the answer is pretty simple, because for green gas it's actually causing some issue, because this lever normally keeps the valve opened longer, which means bigger portion of gas or volume of gas is released. So if you are using green gas, which actually is propane, yeah, so if you are using propane, more propane goes out, which means that more propane evaporates, as propane is liquid in the magazine. So more propane evaporates from the magazine and the magazine gets colder. Yeah, if you reduce the amount of the propane that will go up, yeah, and into the gun mechanism, then the drop of temperature on the mag will be smaller and the cooldown effect will be smaller. So this is what VFC does to protect themselves against the cooldown and improve the system, because they do all these guns with crazy hard kick and so on, which I appreciate very much. But the drawback of this is that they need a lot of energy, yeah, and basically the gun freezes easily. So how you can solve it is either by improving the tolerances and the dimensions on the parts, the fitting, which they also do, because if you see an older and a newer gun of the same type, for example the most popular HK416 A5, there is a really big difference in gas efficiency between the early production and the current productions. Yeah. So this is the reason, but the question is if this is like really beneficial, because finally what you get is reduced output on the gun. Yeah, and you know, most of the people anyway play GBBRs on some arenas where you have maybe 40 meters range tops, and they don't see a difference, because if you have lots of gas ejected, then you have a big cooldown and the gun doesn't work, so basically you are dissatisfied, your gun is not functional, right? But if you have less gas expelled and the gun works, you know, more stable, not necessarily better, but more stable, then you at least can use it, so you are actually, you know, enjoying it. Yeah? So let's put it this way. Yeah, so this is what's going on. But how this is linked with the HPA and why this is a problem, yeah? So with HPA, what happens is that the HPA has a pressure that is given by the regulator on the tank. So everything that travels through the line, whatever mag tap or whatever type of conversion this is, this air is already at the pressure that is set on the regulator, yeah? If you have a magazine with the gas in front here, then you have liquid propane inside, and when it evaporates very violently. If you open the valve, it evaporates, and it's partially liquid when it evaporates, and it's still evaporating, yeah? So in the same window that the air would be released, yeah, propane will be released with bigger volume, so to say, because it's still evaporating, it's still increasing the volume, yeah? And the pressure obviously you can set to be the same, which basically means that the propane is much more energetic than HPA is. So what happens when you take the HPA and you connect it to the gun? Suddenly it loses performance, like the energy, I mean, or the rate of fire, or it becomes sluggish, yeah? And with the APFG MCX it's extremely visible. So here we will see what to do to improve it, but still before I do it, there is a Frog Appendix video, I think number 2, where I taught you how to modify the stock VFC valve. This is a modified valve to increase the length, how much the valve opens, yeah? And this helps because honestly with these high flow valves, it's not really the flow that they are increasing, they are increasing the time when the valve is opened, yeah? So the longer the valve is opened, the more air, in our case, will get to the mechanism, and the more energetic the whole mechanism will be, yeah? More kick and better rate of fire, higher muzzle energy. Okay, so stay with me. I know it's maybe long and complicated, but we are really getting to a point. We modified this valve in that video, it will be linked in the description, to basically open more. And when it opens more, it's like a simulation of this valve knocker retention lever, yeah? It basically takes longer before the valve closes, even if the hammer is resetted directly, resetting the valve knocker, yeah, like in V3 VFC. But it's not so easy, because in the meantime VFC released a new type of valves, yeah, so this is the old type, and the old type has the rear part made of aluminum. You can easily recognize it by this hole here, yeah, on going through it, yeah, and the new type is from stainless steel, and it has no hole, yeah. This type with stainless steel is actually pressed. So this core is fully stainless steel, and this let's say tip of the valve with this button on this side, they are pressed together, and this is not possible to disassemble them anymore without causing damage, yeah? In old valves that are not produced anymore, we had the steel core on this side, then there was the thread, and the rear part you could remove it, modify it, put it back, and you had a nice working valve. So basically these are not produced anymore, and what you get are these now. And for all of V3 GBBRs from VFC is just fine, yeah? If you use it in the conversion from TheFrogEngineer, for example, you put this kind of valve, like the gun will work, yeah? The only issue will be with the APFG MCX. Why it is? The difference is in the construction, because the APFG has a completely different made bolt carrier group than the regular AR15 types. It's much shorter, it's lighter, and what it changes basically is that there is a lot of less inertia for the bolt carrier to start moving, yeah? So how does it work? You put the pressure into the nozzle, the pressure builds up and blows out the BB through the barrel, right? But inside there is the NPAS valve, or the regular one, that shuts off, and when it shuts off, this should be retained strongly in the gun, so that when the valve shuts off, the air has nowhere to expand, so it starts to push the bolt carrier to the rear, and then, you know, bolt carrier disconnects the nozzle and the cycle happens. But what happens in those MCXs is that when the air is coming in here, like the pressure goes to the BB obviously, but as we know from physics, it goes everywhere and it causes the same force on the same surface everywhere in the cylinder. So it's already pushing the bolt carrier to the rear. And in the 5.56 regular AR15 type guns, there is enough inertia of that moving parts here to stay in place as long as the BB is not out of the barrel and the valve doesn't close. Then the whole energy is used to, you know, push the bolt to the rear and the cycle happens. In APFG there is not enough resistance, which makes the gun behave like this. The BB starts to travel, the valve is half opened, and this already starts to open, yeah? And for this reason you have a huge pressure loss, because the pressure from air never gets to the maximum value it could achieve, because the valve is half open, the BB is escaping, and this already is moving. So this sequence, how the mechanism should work correctly, is not maintained. And then there is a question, okay, so what can we do about this? And this is exactly what we will show in this video. And as I said, this change, or this trick that we will do, this modification, you can do also to any other V3 GBBR from VFC, and it will improve the functionality. You maybe don't need to do it, but you can do it and it will be nicer to shoot, yeah? Okay, so this goes away. So now you understand the issue. Our issue is the timing, how long the valve is open. We want to maximize it, right? And because this is really an issue, some manufacturers came with help. So, for example, we can buy a high flow valve, which again, it's not really like high flow valve, it's long time opened valve, yeah? In case you have the old VFC valve, you are lucky and you can modify it according to the Frog Appendix video, explained in the link in the description, yeah? If you don't have it, I recommend you buy this one, the Dragon valve. There is also AMG valve, but honestly I'm not so sure if this is the good valve. I used it for WEs, I used it for some pistols, and I have not seen the VFC, like I have not had it in my hands. But when I will have it in my hands, then I will rate it, but I don't think it will really work well, yeah, that's a question. So what we have here is a valve that has the removable tip. So I'll open this bag and I'll explain you what this is. Bam. Okay, so inside we have the main valve and two additional caps, and those caps are marked. There is either the smooth tip, the tip with one groove, or the two grooves tip is always mounted on the valve in stock. So this valve, it has really nice profile on this side, so it's much better shaped than the original VFC valve. Yeah, let's use the latest one. Yeah, you can see that like this could actually increase the flow, yeah. But what it also has, it has the possibility of removal of this rear part. So what we need to do in order to make our MCX run nicely is to take this kind of valve, put thread locking on that thread, on that pin, and screw it back, but only so much that this surface, this wider surface on that valve tip is even with the valve body, yeah? So this is how much I want it to be, yeah? So the wide portion of the valve is like same plane as the valve body. And I need to stick it in place like this because obviously the thread is a little loose in this position and it would, you know, unwind or, you know, behave randomly. When you have this valve, you drop it into your conversion, whichever conversion you are using for the HPA or the magazine. And you see I already have one here, yeah, the silver one. So what it will do, it will increase the time, because now the hammer, when I release it, it will push the valve more inside, and basically the valve will be open for longer, and when the gun will reload, more energy will go into the bolt carrier. So this is the first trick. And now the second trick. This is regarding the VFC hammer. So let's take it out, let's show it a little better. Okay, this is pretty easy. You just need to punch out this pin, and you can do it in any hammer position. Okay, so there is the pin. Now I can release the trigger and it jumps out, yeah? And be careful not to lose the part. So you have spring, you have two washers on the sides, and there is like a round spring inside that retains the pin, yeah? Okay, so I'll take this off. Okay, see the round spring, and we look on the hammer itself, yeah? So the hammer has a screw. This is M2.5 screw here in the front. This is supposed to be, you know, screw in, screw out part to regulate the force on the valve knocker. The issue is they are using extremely short screws. So this is the screw that was there originally, yeah? and you are not really able to regulate much. If we now look into the lower receiver, we will notice that apart from the fact that the valve now opens more, additionally you can push in the valve knocker more. Yeah, it hides in this steel part here. You can push it all the way deep in there. Yeah, so this is what we want to use, because when the hammer strikes forward, it actually stays on this steel part, and what we want to do is we want it to push this even more, like to the maximum depth possible, and again release more air going forward and then going backward when the gun is reloaded. We cannot just use the regular stock screw in the hammer because it's round and its diameter is bigger than the opening for the valve knocker, so we need to do a trick. And the trick is simple. I already have the modification done here, but I'll explain how to do it. It's like trivial. You take M2.5 times 14 cylindrical screw, and you screw it in all the way. You see this hole actually goes to the other side, and the reason why you take so long screw, because the thread is ending and the M2.5 times 14 is long enough to reach this area where the thread is ending, and you can force it a bit, yeah, and it will not undo itself like this short screw from the stock VFC is using. Yeah, so you use this M2.5 times 14 screw and you screw it all the way in until it sticks out 1 millimeter. So you see mine is sticking 1 millimeter plus minus. Yeah, so you do it like that, and then you mark the orientation. You make two parallel lines, because what you need to do is to file off the sides of the screw. Yeah, like I filed off the sides of the screw, because I wanted to go deep into that groove where valve knocker is. Yeah, and then free screw would be too big. So you mark two parallel lines, then you remove the screw, you file off the sides of the screw to make it rectangular on these two walls, yeah, two parallel walls, and you screw it back to this position sticking out 1 millimeter, and you get to this step that I'm on right now. Yeah, so after you do it, obviously you will need to reassemble everything, but before I do it, I'll show it again, so check it out. So here I want this screw sticking out from the hammer to, you know, go deep enough to push it more than the steel part, like stopping the hammer. Yeah, so the hammer will stop on the steel part, but the screw sticking out will push it a little more. If I take the original screw, the head is so big that it doesn't fit into the groove or the opening for the silver part. So this is the reason why I need to file off the sides of the screw. And why I said 1 millimeter, because 1 millimeter is plus minus the correct value. M2.5 times 14 screw, if I remember correctly, has a pitch of 0.45 millimeters. So now when we have this screw inserted like this, when we turn it and we turn, like, screw it deeper or more shallow, we basically move it in 0.2 to 5 increments, 2 to 5 millimeter, obviously, increments back and forth. Yeah, so this is basically what we want. Okay, now enough talking, let's assemble this all together. I need to put it back in. As I said, my part is already modified. Unfortunately, I did not think about recording this video prior to making this modification on this gun, and at the moment I don't have any other on which I could do the modification to show you. But anyway, okay, so the hammer is here. Okay, so the hammer is back in the gun. So where I cock it right now and I pull the trigger, hammer goes forward, and I want to focus on the hammer, if this is on touch with the steel part here or not. Because if it is on touch, then probably I could increase the amount of the distance that the screw sticks out from the hammer, and this way I will push in the valve knocker a little more. Yeah, of course mine is already set, but if you will see something like this, that the hammer stays not in touch with the steel block in front, it means that the limit part is not the steel block but the valve knocker, which you don't want to have, because sooner or later the retaining part for the valve knocker will break off and basically the part will, you know, be broken. So you don't want this to happen. What you want is that the hammer pushes the valve knocker inside as much as possible, but it stops on the steel part. So now, by turning this screw, even like without removing the hammer, you can access it. You can turn it halfway back or forth, and you can set it in this perfect position which will be pushing the valve knocker as much inside as it can, while still having the hammer rest on the steel part when it's released, not on the valve knocker. Yeah, so you set it. So we are almost at the end, right? So what this will do, this will maximize the time the valve is open. Yeah, so maximize the time the valve is open. It will allow you to use any kind of hard kick, whatever springs you want. I know that people are having trouble with the APFGs, that they cannot like fully cycle, and because the springs are too stiff and so on. This is because there is not enough gas released. So this way you can release more gas. And again, I'm saying this for like third time, but you can also do this in regular V3 VFC gun exactly the same way. The trigger group and this whole assembly here is identical as in any AR15 or HK416 type gun from VFC. Okay, so the last thing to be like shown in the video, which would be nice obviously, is to connect the pressure and show you the effect. Yeah, so here is the effect. This is how it works on HPA currently, the semi. Like the kick is very strong, and honestly on HPA this is 120 psi, so it's not high pressure for the like compared to green gas, and the kick is much nicer and stronger than in the stock gun. Yeah, on the green gas I mean. Let's do some full auto. Yeah, it's very loud, it kicks very hard. The rate of fire in the HPA GBBRs is always a little limited by the regulator, but you know, it's fine. And also the NPAS setting plays a role here. Yeah, so theoretically I could go with the pressure up and dial less NPAS, and the rate of fire would increase even more. Okay, so for the moment that's it. This was highly technical video with the description. I always think that it's good to understand what you are doing and why you are doing it, instead of me just telling you file this off, replace this part and you will be fine. Yeah, it's always better to know why you do it and what it is. So thank you for the APFG, the MCX. This one will come back on the channel probably more than once. If you want to get some information regarding a conversion used in it, it's a regular Gen 2 TheFrogEngineer HPA conversion for the VFC AR15s. It fits perfectly, no issues. So if you are interested in getting one, please contact us. But other than this, I think this is all for now. Thank you so much for watching. Hit the notification bell, subscribe, like, and in the comments let us know what you think. And as always, may the power of GBBR be with you.